Hello everyone and welcome. So today I will be helping you with the coordinate plane and questions relating that. So this time I'll be talking about a more advanced look on the coordinate plane, not just graphing points and finding the distance between those. So let's first begin with drawing a coordinate plane here. So this is the coordinate plane without the grid, and we can graph different types of functions here, and also graphs that aren't necessarily functions, such as hyperbolas. Alright, so we will in this video graph different types of functions and see how the correct approach to those is. So we did some of those in the functions video, and in that one we graphed functions to see if they were functions or not by finding if every x value only had one y value. But today we'll just be focusing more on graphing the functions. So let's first begin with graphing the slope function, which is kx plus b, y equals kx plus b. And note that it sometimes is also represented as y equals mx plus b. But nevertheless, k and m are both the slope, and b is the y-intercept. So for this b, you would have the y-intercept as 0, b. So for example, if you had a y equals 2x plus 5, the b here would be 5, so that means the y-intercept is 0, 5. So let's just graph that here. So this is 0, 5. And then the next step to that is would be graphing the actual line, and to do that we need the slope, which in this case would be 2. So 2 here, that means that we need a change in y by 2 and a change in x by 1. So 2 here is the rise over the run, and that is basically the change in y over the change in x. So these two are the same here. Alright, okay, we would take these 2 points here, these 2 points, and we would make a line intersecting those two, and that would be our graph for 2x plus 5. Or let's do a different one, this time without the this time not in the form of y equals kx plus z. So instead, let's graph a parabola. Alright, so parabolas are functions that look like this, or this, or like some other way. In between those, it can be shifted right or shifted left, and it can also be shifted up or down. So in this case, let's just graph y equals 2x squared plus 1. Alright, so first thing we can see is that we need the vertex first. Now the vertex is the point that is the lowest or the highest of a parabola. In this case, since this is a positive, we will be looking for the low, for the lowest point. But before that, we can also see that we have a y-intercept of 0, 1, which, since we have that, it would be our vertex for this case. Or so note that the y-intercept is always the vertex for parabolas. So 0, 1 would be our vertex for this parabola. Or let's graph that here. So this would this is how a parabola looks like, just that we haven't found the other points yet. So this would be our vertex, and then the next step is to find 2 other points in order to get a very accurate parabola here. So that would be how you would do that. And in order to do that, we would have to have negative n and n and plug those two values into this function. So these two values, you can pick pretty much any value, well, positive value or negative value. It doesn't really matter, since you would always get the same thing in the end. But for this case, we would just do -1 and 1. So we will plug these two values into this function here. So this would be 2 times -1 squared plus 1. So this is 2 plus 1, that's 3. And we can plug in 1 into here. So that's 1. Plugging into this x spot right here, that's 2 times 1 squared, which is 2 plus 1. So that would also be 3. So that means our 2 points would be -1, 3, and 1, 3. So those would be 2 of our points on this parabola. So that would be the graph for this one. So there are other graphs, such as x to the power 3, x to the power 4, x to the power 5, and so on. And different forms of these when they're shifted in all 4 directions, or changed in width and height and things like that. So we'll just graph x3 plus 3, and we'll just take that as an example. So x to the power 3 plus 3. So first thing, the y-intercept is 0, 3. And next thing to know is that a graph of x to the power 3 looks like this, just as an example. So we would have it like this. And on higher levels, right here is also an inflection point, but that is more of a higher level. So that is just something to know. Or let's try some problems regarding these. Alright, so first one, it says to graph x plus 2 to the power of 2 plus 3. Alright, so here, let me bring this over here. Alright, so I didn't really talk about this type in the first explanation for these parabolas. So this one is also parabola. So this one does not have a coefficient. Well, its coefficient is just 1, so we can just go ahead and just graph it like a normal parabola. But over here it says plus 2, so that means we would shift it to the right, to the left. If it was minus 2 instead of the plus 2, then we would shift it to the right, not the left. But since this is plus 2, we would shift it to the left, to units. So this would be 2. Here, 2, 0. And we also have plus 3, so we would have 3 here. 0, 3. So we would have the vertex 2, 3. The next step in this would be finding 2 values that are in the form of -n, n. But since this is minus 2 in this case, since we are shifting around, even though it says plus 2, we would have to do a minus 2 here. So we'll just do well, we'll do it from 2, and then we can shift it 1 each. So this will be 3 and 1. So we would shift it here. This is -2, but we would, since it is shifted to the left, we would have to put a negative sign in front of those 2 values. So those 2 would have -1 and -3, and then we would plug that into here. So -3 plus 2 equals -1. -1 squared equals 1 plus 3 equals 4. Same can be said about negative 1. Negative 1 plus 2 equals 1. 1 squared equals 1, and 1 plus 3 equals 4 as well. So we would have these points here. Here, let me just do these, and so we would have these here, and we can have the values negative 3, 4, negative 1, 4, and then we'll just have this, and then we can just graph it like that. So this graph is a bit rough, but it's still a pretty much rough graph of x plus 2 squared plus 3. Alright, so let's move on to the next one, which asks to graph 2x plus 6. So we'll just move that over here and graph that there. Here, let me, okay. So 2x plus 6 is in the form of y equals kx plus b. So we can just have the slope of 2 and a y-intercept of 6. So 0, 6. And we'll have 8 up here and 1 down here. And then we can just pass through these 2 points. So this would be the graph for 2x plus 6. Alright, let's move on to the third one, which asks to graph x to the power 3 plus 1. So x to the power 3 has a y-intercept, a y-intercept of 0, 1. And since this does not have any values that widen it or narrow it, then we would just graph a typical x cubed function. So this would be like this, and with the y-intercept being at 0, 1. So this would be how we would do this one. Alright, so let's just do the fourth one, which asks to graph 6 minus x squared. So we can simplify this into negative x, well, not simplify, but rearrange the terms into negative x squared plus 6. So we would graph that here. And firstly, we would have the y-intercept be 0, 6. And then we would have negative x squared, which is the parabola. So note that this is a negative, not a positive, so that means it would be facing downward. And which would also mean the vertex would be the highest point in this entire parabola. Alright, so we can see that the vertex is 0, 6, since that is also the y-intercept, since it does not have, since it does not shift to the left or right. Alright, so we can just have this as a typical parabola, and then we can have negative 1 and 1 here, and we'll just plug those into here and see what we get. So negative 1 squared equals 1, negative 1 plus 6 equals 5, so this will be negative 1, 5, and same can be said about 1. 1 plugging into here, 1 squared equals 1, negative 1 plus 6 equals 5 as well. So we would have that there, and let's go on to the very last one. This one asks to graph x equals 3. Alright, so this one is fairly simple. So, x equals 8, not x equals 3, sorry. So this one we can just do all the times when x equals 8, what just happens to be when 8 is here. Okay, so when graphing x equals something, it is always a vertical value. When we're graphing y equals something, it is always a horizontal value. So in this case, we're graphing x equals 8. So we would just graph a horizontal line at x equals 8, which is right here, and that would be our graph. just simple enough, and that just ended our quest lesson for today. So thanks for watching. Please subscribe. Thank you. And also, if you have any questions, feel free to post those down into the comment section. Thank you.